Hello, good afternoon. I think it's time to start this workshop. Welcome to everyone to the Sustainable Mobility e-mobility workshop. Thank you for attending this workshop. Of course, you can participate in our poll, in the survey at the end of this workshop, and during the presentations, you can ask questions by means of the chat. And also you are invited to join us on Twitter, Sustainable Places 2020, and enjoy this workshop. First of all, let me introduce myself. My name is Patricia Bellver. I work in ETRA as a project manager, and now I'm the project manager of MEISTER, who is the project that is sharing this workshop, this e-mobility workshop. Today with us we have 4 other speakers apart than myself. They are representing several European projects related to e-mobility, and later on I will present each speaker at due time. Okay. Yeah. Welcome to everyone, as I said. And some rules in order to follow the workshop properly. The speakers should mute their microphone and switch off the camera while they are not talking. Of course, during their presentations, they are invited to switch on the camera. And please, speakers, stick to the time slot you have allocated. And for the attendees, of course, feel free to ask any question, add comments to the chat while the presenters are talking. Okay. Well, and here you can see the agenda for today's workshop. First of all, we are going to present the MEISTER project. Myself, it will be myself who will do it as a project manager of this project, as I said before. Later on, we will know about the UserChi project, Innovative Solutions for User-Centric Charging Infrastructure. It will be presented by Maria Tomás. After this session, we will hear about GreenCharge project, GreenCharge measures and impact evaluation framework. By Marit Natvik of Sintef. Then we will hear about the analysis of electric vehicles cost-based charging load profiles from Sotiris Deligiannis of the University of Peloponnese. And the last session will be devoted to electric vehicle charging infrastructure for improved user experience from Dr. Evangelos Karpopoulos. Sorry for the pronunciation in Greek. And then the last part of this today's session will be devoted to roundtable questions and exchange of impressions. And then we will close the session at 6. Okay. So, as I said, first of all, I will present the MEISTER project. Yeah. Here you can see MEISTER project stands for Mobility Environmentally Friendly, Integrated and Economically Sustainable through Innovative Electromobility Recharging Infrastructure and New Business Models. It's a long title, but it's a straightforward project. So here you can see in the map where the partners of this consortium are located. We have several types of partners here in the consortium, so it's really well balanced because we have the public entities, the City Council of Malaga, Berlin, and Stockholm here, and also we have industry partners as ETRA the ETRA partners that are ourselves, the coordinators, Novadays, VMset, and ION. Also, we have research centers on board, ICAM, RIS, and CERT, and the housing company that is Gegobag in Berlin, located in Berlin. Okay, so that's some tips about MEISTER project. Sorry. The challenge of our project is to change the paradigm in the electromobility market, providing interoperable platforms, services, with the goal of achieving an easy, convenient, and barrier-free access to charging, billing, and smart grid services. So this is our, let's say, motto of the project. We started the project, or the kickoff was in September 2018. And here you have all the countries that are participating in the project. Also the pilot sites that, as you may imagine, are located in Stockholm in Sweden, Berlin, Germany, and Malaga in Spain. Our strategic goals are as follows. The innovative and sustainable business models for smart e-mobility, the deployment of an e-mobility interoperability platform that will allow an independent, non-discriminatory information authentication and billing schemas that assure this interoperability. The third one is the integration of e-mobility in the city's SAMPS, sustainable urban mobility plans, and the city planning process. And last but not least, the integration with the smart grid services. In MEISTER, we are developing several products. We have designed them and developing it along the project lifetime. And this, we consider that these are one of the main outcomes of the project. Product number one is what we call the MEISTER Replication Market Uptake and Deployment Handbook. It's a kind of tool set that will collect the main project results that will include the business models that we are defining in the project, how to use the technological solutions or the other products that I will present later on. And also it will include practical results from the business models. The value added of these services include the lessons learned from the real application and validation of the solutions and the products within the project. The second product or result of the project will be the MEISTER roaming and accounting platform. This platform will allow this independent access, non-discriminatory and convenient and barrier-free to the charging infrastructure or the charging points, wherever the charging points are located, whichever electric vehicle is used, and whoever operates the charging point, and whoever supplies the charging service and electricity. The value-added services of this product are that transparent business-to-business services, and that these services use open standards and most used protocols for roaming. Here you can see some screenshots of this already developed platform for roaming and accounting in order to manage properly the charging infrastructure. Some technical hints. This platform uses OCPI protocol for the integration of e-mobility service providers and charging point operators. Another product interesting in MEISTER is the integrated real-time information and booking services. This is a compendium of different solutions, different developments, software developments, as for example, the smartphone app for EV drivers and e-mobility display for housing services. Also applications for urban logistics companies using electric vehicles, and a smart e-mobility dashboard for the city management or for operators, and of course a backend for the integrated services. Some added value services that provide this product are combined smart park and charge features, monitoring real-time information about public charging points, searching and routing to a specific charging point, booking of parking slots and charging stations as well, and several customized services for different or specific end users, such as the urban logistics companies. Here you have, sorry, as well several screenshots of the different applications. Here in the center you can see the e-mobility display, and here, for example, the dashboards that allow an operator or a city manager, city planner to check the real-time status on e-mobility services along the city. Another product or result of the project is the MEISTER European E-Mobility Expertise Center and SUM's knowledge base. We call it MEC here, as you see. And this product is already available. It's here you can see the website where this product is shown. Sorry. This product is shown. Of course, this product has its own dissemination channels on Twitter and on LinkedIn. And I'm going to explain several things about this EMEC. This is a non-profit organization created by the project to facilitate or enable the transferability of best practices to other cities, other governments. It's a technical, legal, and financial support center, and a tool to enable engineering and consultancy companies to offer the services to local governments in terms of e-mobility and how to integrate it in urban planning. It is established in Valencia, in Spain, where ETRA is located. And some hints about the mission, the vision, and the values of this association. Our mission is to build a greener, CO2-free mobility future in Europe. Our mission is to ensure the more efficient use of the urban space and mitigate the adverse traffic effects by means of the smart e-mobility solutions. And our values are the collaboration, electrification, sustainability, and ecology, of course. Here you can see some of these MEC services that mainly are focused on e-mobility studies and analysis, networking and fundraising, of course, business consultancy services, and sharing of best practices. And last but not least, this is the product number 5 in MEISTER, that is the smart charging and storage platform. This platform allows vehicle sharing companies and e-fleet managers to optimize the activities related with smart charging and the charging of their electric vehicles. This allows the dynamic distributed storage of devices in electric vehicles, and also the vehicle-to-grid technology supply. This allows to optimize the use of renewable energy into the charging of the vehicles. Also, different types of charging on demand, smart charging, or the vehicle-to-grid technology that I said before. And the main benefit is to stabilize the grid, doing this kind of demand-side management. Here you can see the 3 different pilot sites in the MEISTER project, the 4 main objectives that I mentioned before at the beginning of my slides. Also the products I have mentioned, the results of the project, and which business models are going to be or are being studied and will be demonstrated and tested and validated along the project. So, for example, we have several business models as the e-car sharing as a housing service that will be tested in Berlin, the e-car sharing in a municipal fleet that will be tested in Malaga, also the city logistics business model that as well will be tested in Malaga, and in Stockholm a specific business model will be tested, that is the delivery of home care services with electric vehicles. And there are 2 other business models that are horizontal to the 3 pilot sites, that are the smart park and charge and the smart charging business model. So here in this figure, you have a good summary of what is intended in the MES project and what is going to be developed. And now just a brief introduction on the different pilot sites and the different ideas or business models that will be tested. In Berlin, they are going to focus on the business cooperation frameworks and smart mobility services for new urban planning in new apartments. In Malaga, they are going to focus on urban collective logistics, like last mile distribution with electric vehicles, and also in municipal e-car sharing schemes. And in Stockholm, they are going to focus on the services of home care delivery with electric vehicles. And here some photos and some basic data about the pilot demonstrations already in place. In Berlin, in this case, in this demo site in Falkenberg, it has been deployed during August this year. And here we have the car sharing as a housing service business model to be tested for several months. Here, in order to test this car sharing service with electric vehicles, the users will make use of the mobility app developed in MEISTER in order to check the availability of the service, the vehicle, and the charging point, and start and make a reservation. Following with this business model, but in another demo site, in this case in Mariendorf, sorry. Here, 3 electric vehicles, electric cars have been dedicated to specific charging points, and also here parking barriers have been installed in order to guarantee the availability of the parking lot and the charging point when the vehicle arrives to the parking lot. By means of the MEISTER mobility app, the user can make this reservation in due time. Here you can see another business model, that is the smart park and charge in Lindenstrasse, in another demo site in Berlin. Here the combination of the parking barriers and the charging infrastructure in order to guarantee the accessibility to the charging point. 2 AC and 2 DC charging points have been installed here, and the drivers can access to the charging point or have this access guaranteed, let's say, by reserving or booking the barrier that only is open when the user is near this barrier. Okay. And yes, yeah. So there are several products or several developments involved in this sites demos that I have shown before. The MEISTER mobility app and the MEISTER mobility display, that is this one you see in the photograph. And this is all from my side. If you have any question, please feel free to do it in the to post it in the chat. And now, according to the agenda, it's time for Maria del Carmen Tomás for presenting us the UserChi project. I'm going to pass the role to Maria, and in the meantime, I'm going to present her. Maria holds a master in industrial engineering from the Polytechnic in University of Valencia. She worked as electronic systems engineer at Nissan Technical Center Europe in Barcelona, in Spain, and an international R&D consultant in CDT, that is located in Taiwan, Taipei. She's currently project manager at ETRA and is the project coordinator of UserChi. Maria, please proceed.
Hi, Patricia. Good afternoon. Good afternoon, everyone. Thank you for moderate this workshop. As Patricia said, I'm Maria Tomás. I'm project manager at ETRA and the project coordinator of the UserChi project. Okay, today my objective is not to present results done in MEISTER because we are in our first year. But my objective today is to explain how we are working in UserChi and what is the meaning of the project. In addition, I would like to share with you some of the results obtained from the user research, which is being performed in Work Package 1. Okay. Okay. UserChi will design, develop, and demonstrate a set of innovative solutions, but the difference is that we are focusing and putting a special effort in the user-centric approach. We understand that the needs, understand the need and patterns is essential to deliver good solution to the market. And sorry, when we are talking about drivers, we are focusing, of course, in electric vehicles, but also in internal combustion engines, vehicles, and light vehicles, because we see a clear intention of the citizens to be electric, and we should offer a user-friendly and user-friendly ecosystem to allow it. Okay. Which is the context? I mean, where we currently live. As we know, currently most of EV owners have their own garage and live in peri-urban areas. The market share of full electric vehicle is still low in many European member states. Current business model and revenues from charging infrastructure are not enough to ensure a sustained market growth, and innovative solutions are required to allow EV drivers having a similar mobility experience than with conventional vehicles. Moreover, if we check the EV-related news in the last year, we find that the focus is being transferred from the electric vehicle to the charging infrastructure, where in the previous years, the main problem were the autonomy range, and the prices, nowadays we find that the charging concerns are the new blocking point for the electric mobility take-up. Sorry. Okay, as I said at the beginning of my presentation, in UserChi we are putting an special effort in the user perspective because we think that the users have the key to unlock the electric mobility market. If we understand the needs and patterns that have the drivers and we design the user-centric solutions to increase the user experience, we will have taken a big step forward. According to our user research study in Work Package 1, we find that electric vehicles drivers are more satisfied with the vehicle than with the charging experience. In brief, user rate with 3.9/5 the adequacy of the charging points used, with 4 to the suitability of the plugs, with 3.6 to the waiting time, and with 3.8 to the quality of information they receive about the charge. From this data, we have identified the challenge, which is support the accelerated deployment of EV charging infrastructure in Europe by ensuring user satisfaction. Here, I show you some data of the project. As I said before, we are in the first year. The project will last for 4 years, from 2020 until 2024. The budget is 17 million, and our consortium is composed by 24 partners. Nowadays, we are ending the preparation phase and starting the development phase. Our team is composed by 24 partners from 6 countries. It's a balanced team of complementary organizations that covers the overall value chain of the projects. We have research centers, technology providers, standardization bodies, end user, public bodies, etc. Our solution will be demonstrated in 5 demo sites: Barcelona, Berlin, Budapest, Rome, and Turku. And since large-scale replication is one of the cornerstones of the UserChi projects, two replication cities, Florence and Murcia, will replicate some of the results of the UserChi project. Okay. I think, sorry, but I think the slides are not working very fast. I would like to go behind on the presentation. Sorry. Okay, regarding the objectives, we have, we will provide an optimal design of charging network with an user-centric approach, the deployment of an interoperability framework and platform, and a scalable infrastructure rollout by means of a smart grid integration, the development of innovative and highly convenient charging systems, the demonstration of novel business and market models, and the legal and regulatory recommendation for the massive EV deployment. These objectives will be materialized in 8 products. The first one is Click, the charging location and holistic planning kit, a handbook to design on how to design the station of the future, the MOBEST, the mobility replication and best practice cluster, Infra, which is the interoperability framework, which is linked with INCAR, which is the interoperability charging and parking platform, SMAC, there is the smart charging tool based on dynamic charge management, INSOC, an integrated solar DC charging station for light electric vehicles, and Inducar, an inductive charger for e-cars. Now, let me share with you some conclusions that we have recently obtained by our user research that is being carried out by IBB, one of our partners. This is the netnography results that are part of this user research. Netnography is an online research method related to data analysis and data collection based on user observation. In UserChi, we have been observed some online forum of EV drivers in 3 countries, in Norway, in Germany, and in Spain. Regarding the sample, we have collected 183 mentions from 123 users in Germany, 232 mentions from 175 users in Norway, and 472 mentions from 212 users in Spain. Then we group all of these mentions in 4 big groups. There is electric vehicle, infrastructure, incentives, information, and environment. It is surprising that, for example, while in Germany, the most important the most important group are infrastructure. In Norway are incentives and information, and in Spain is electric vehicle. It can be related to the different EV penetration rates in the different countries. We have Norway, which is the country with the most with the higher EV penetration rate in Europe, and maybe to the differences in the number of the charging points. For example, here we have the data, and while in Germany and Spain we have 1 charging point for each 9 or 10,000 inhabitants. In Norway, they have 1 charging point for each 2,000 inhabitants. From this study, we have obtained some shared opinions among the 3 countries. Something that is common is the lack of maintenance of the charging network. Many times there are internal combustion engines or electric vehicles not charging, occupying the charging points. There is a need for route planning and charging services for the long trips. There is still incompatibilities between network and chargers, and there are deficiencies in the charging points. We have also some specific experience related to each country in particular. In Germany, users ask for solutions for extreme weather, standardization and interoperability for the access and payment, a more extensive public charging network, and better maintained, and to improve security. In Norway, user complains because Tesla is the largest charging network and they prioritize these vehicles. And problems such as network shortage and also interoperability issues. For example, multiple operators, different access forms, payment, and high prices. While in Spain, users ask for more charging points. We don't have many charging points, and the largest network is in the north and in bigger cities. The user also complains for they don't have information and they don't know how to use the charging points, and there is no public charging network, and the existing private one is slow. Okay, some curiosities to conclude with these ethnography results are that the long-range vehicle users are more satisfied with the charging infrastructure network than low-range. The most developed EV market Europe is Norway. The user presents fewer incidents related to the vehicle and the charging infrastructure network, and more contributions related to incentives and information. German market also presents a good penetration of EVs, and the EVs valuation of German users is similar to Norwegians, and they have an special interest on improving infrastructure, probably due to population density. And Spain is the least developed market of the three studies, with the lowest percentage of electric vehicles. This market does not have public networks, and charging systems are not standardized or poorly standardized. Some proposals that came up from the study is to adapt the availability of chargers in the services with a higher demand, to increase these low charging points in shopping center and supermarket, to allow charging while buying, to improve the management of charging points in public parking, free charging linked to minimum purchase, let the user adjust time and charging power according to their needs, and to develop guides and information about the European charging network, national operator, compatibilities, payment, etc. Okay, this is all I wanted to share with you today. Only I like to remember that you can get involved through technical webinars and replication webinars, policy and research recommendations, project events, and you can follow us in social networks. We are in Twitter and in LinkedIn, and you can also check visit our website. It's userchi.eu, very easy, and you can contact as well by email. Now, yes, this is all from my side. Thank you very much for your attention.
Thank you, Maria. Thank you very much for your presentation. Let me, before introducing the next speaker, let me pass the floor to Raquel Castañ. She is our dissemination manager in MEISTER, and she is, of course, supporting me in the organization of this workshop. She will be in charge of launching several polls along the workshop, so you can, of course, answer these questions and interact with us and help us with the polls and the surveys. Please, Raquel.
Yes, hello everyone. Thank you all the attendants for joining us in this webinar. Just to break a little bit the ice, we would like to ask you some questions in order to know you a little better. So here is the first question. So it's quite easy. So have you ever heard about the project that we are presenting today? So I will let you a couple of seconds. Okay, I will close this question. So, well, it's 50-50. So some of you, the half of the audience knows already these projects, but the other half doesn't know. So yes, I hope with this workshop you will get more information of these projects on e-mobility. So here, next question I would like to ask you is what interest do you have in MEISTER project? So after the presentation of Patricia, what are you interested and get more information after this project? So business models, integration of e-mobility in the cities, integration with smart grid services, or e-mobility interoperability. Okay, I will close this question. I will show you the results. So yeah, 60 more than 60% are interested in the interoperability, and the 50% in the integration of e-mobility in cities. Thank you for your answers. We will go with another question. Well, we will need to know you. So what is your energy sector, where you come from? Academic or technological center, municipality, industry, operators? Okay, I think most of you have already answered. So the 50% came from the industry, and the more than 30% came from the academic and technological centers. So just another questions that we will end up with this poll. So here we would like to know what is the main obstacle in relations to today's e-mobility phase for a successful energy transition. Okay, I will close this question. So most of you think that there is a lack of recharging stations, and also more than 30% of the audience thinks that the high cost of vehicles it's an obstacle. Another interesting question that we would like to ask you also: do you think that the user perspective in being considered the current EVs charging infrastructure and services? Okay, so I close this question. So it's quite impressive, because the 100% of you thinks that no, they don't think on the user perspective, which is quite significant actually. So the last question during this round is: which are the main barriers for long trips with fully electric vehicles, do you think? This is the main barriers. Okay. So here, most of you think that there is a lack of charging points, and another percentage of people thinks that there is a low range of electric vehicles. Thank you for the audience that have participated in these polls. Thank you very much. I pass the floor to Patricia, who will introduce the next speaker. Thank you very much.
Thank you, Raquel. I guess that the results of these polls are really illustrating the reality right now. So next point in the agenda is the presentation of GreenCharge project, the measures and the impact evaluation framework. Marit Natvik is the one who is going to present these slides. She's a senior scientist in SINTEF, which is a large multidisciplinary research institute in Norway. She has a background from software engineering, and she has worked in the area of smart cities, smart and multimodal transport for more than 20 years. She has been leading research projects, national research projects, and participated also in European projects. In GreenCharge, she's the evaluation manager. So please, Marit, you can proceed. I pass the control to you.
Mm-hmm.
Okay.
I cannot, yes, there it is. Thank you very much. So, hello everyone. I will present the GreenCharge project, which is about charging of electric vehicles. And I will talk about the measures that we take regarding mobility and charging at the different demonstrator sites and the evaluation of these measures. Yes. Europe aims for a zero-emission transport sector, and e-mobility is a very important part of this solution. And in such a future, charging must be available to everyone, and we must charge with green, renewable energy. And as far as possible, the charging infrastructure must be established without high investments in the power grid. So in GreenCharge, we address many of these barriers. So the barriers are, among others, that the EV user don't know or they worry about where to charge. And there is also people, or the businesses, they hesitate to invest in the charging infrastructure. And we must also avoid that the limited capacity of the power grid becomes a showstopper with respect to charging. So in GreenCharge, we address these barriers by defining a set of measures that should be taken to overcome these barriers. We also develop technologies and business models regarding this to support these measures. And we demonstrate these measures at in 7 demonstrators in 3 European cities. The cities are Oslo, Bremen, and Barcelona. In Oslo, we have 2 demonstrators, one with home charging for apartment residents, and one regarding the pre-booking of charge points. In Bremen, we focus on charging at work, and also the charging of shared EV fleets. In Barcelona, we also address charging at work and electric bikes, shared electric bikes and e-scooters, and battery swapping instead of fast charging for the e-scooters. In all cities, we contribute to the city goals regarding mobility and also to work on sustainable urban mobility plans. And we focus on energy management regarding linked to the charging, and we also focus on charging with green renewable energy and business models. So it's not enough just to demonstrate the solutions at the demo sites. We also have to learn from the demonstrators. So we have to learn what is a success, what is a failure, and why was it a success or a failure. We also have to learn about the possible impact and to achieve, how to achieve the desired impact in different contexts. To be able to learn all this, we need to do evaluations. It's very slow when it changes. Yes, we need to do evaluations. I'm not able to switch. Someone else is moving the pointer, I think. Do I still have the control? Yes, there it comes. So we have to evaluate the results, and we have to evaluate the results in a scientific way so that we can really trust the results and know that we have the right knowledge about e-mobility and charging. So we do this by having these 7 demonstrators, and they all demonstrate a subset of measures regarding e-mobility and charging. The measures that we demonstrate in one demonstrator is adapted to the local needs and the local context, but we also demonstrate the same measure at different, more than one demonstrator, because it's very important to learn from different ways of implementing the measure and also how the measure will work in different contexts. So we have these 7 demonstrators, and they will deliver data. We collect a lot of research data from the demonstrators while they are running. And this data is also input to simulations, where we simulate scenarios that we are not able to show in real life. For example, we can simulate scale-ups, what will happen when all vehicles in an area are electric, or what will happen if we have more renewable energy sources. And also we can simulate things that it is difficult to realize with the current technology, for example, vehicle to grid. So the simulations will also deliver research data, and the research data is input to the evaluation and learning. Yes, we have a very strong focus on what we call smart charging. That is charging with smart energy management. And this diagram shows the use of energy in a parking garage, which is one of the demonstrators in GreenCharge, where there is no charging here. We just show the normal energy use, but there is a limit in the capacity in the power grid represented by this red line. If we charge 30 vehicles, we see that the peak is very close to the capacity limit. So then we might have problems. We may not be able to charge all the vehicles as we want to. With smart charging, we are able to shave the peaks and to flatten the curve. We use energy when there is capacity available. So we manage to flatten the curve. So this is a very important concept, to be able to charge more vehicles in the existing power grid. So I will go through the different measures that we focus on in GreenCharge. They are grouped in 4 groups: the charging, smart energy management, business aspects, and EV fleets. I will not go through all the measures in details. I will just mention those that are of particular interest, I think. But as we see here, they are implemented in the different demonstrators in the 3 cities, and some of them are also simulated. Yes. So, for example, we have one measure that is the booking of a charge point. That is pre-booking. That will provide more predictable access to the charging to the EV user. And when we realize that, we can see how it's work in practice, because it's very important to see if that is a service that the user wants, or how they will use it. Will they leave? Will they remove the vehicle when the time slot they have booked has expired, or will they stay there longer and block the charge point for the next customer? So it's important to test that. We also have a measure that is to share private charge point, to let others use the charge point when it's not used by those who own the charge point and use it usually. With respect to smart charging, we have quite many measures. The most important one is perhaps the flexible charging. That is that the user allows the charging to happen at any time, as long as the vehicle is charged before a certain deadline. So the EV user say how much energy he or she wants, and the vehicle is charged when there is a capacity available in the power grid. And the flexible charging actually arrange for or makes the smart energy management, as I showed you in the diagrams before, possible by being flexible about when the vehicle is to be charged. Priority charging is the opposite, is that the EV owner says that the vehicle has to be charged immediately and as fast as possible. We also use renewable energy sources. This is a picture from the garage in Oslo, which is a part of the demonstrator there, where we have PV panels on the roof. And we also have stationary batteries for the storage of energy, so we can store the green battery from the roof and use it when it's needed. Vehicle to grid is not demonstrated in real life. We will just simulate it, because normal vehicles doesn't support vehicle to grid in Europe today. And of course, we do the optimization to be able to flatten the curve and remove the peaks from the energy use. Regarding business aspects, we look at how to promote desired behavior. So we will reward flexible charging, and we will penalize those who are blocking charge point after the booked time slot. We also look at how to business model for the sharing of private charge point to let the public charge them when the charge points are not in use. And we also have measures related to EV fleets. I will go in detail into the demonstrators in Oslo. Here we have what we call a housing cooperative. The residents own the buildings and also the assets together. And in this case, it's 5 apartment blocks with 246 apartments. They also have a common garage, and they also have 4 charge points outside the garage. So in the garage there are 230 parking places. So it's a potential for 230 private charges. The 4 charge points outside the garage are owned by the housing cooperative, but they are shared with the public. So, and the public has to pay, so that will generate some income for the housing corporation. Yes, I will focus on this first demonstrator now on the next slide. So here in the garage we have installed 60 charge points, and currently more than 30 of these charge points are in use. We have PV panels on the roof of the garage, and we also have stationary batteries for storage of energy that is not used at the moment. The users have to use an app to start charging, and they will also provide input data like the energy demand. They have to select between priority and flexible charging, and they also have to provide a deadline if they choose priority flexible charging. And we do smart energy management to optimize the use of the grid capacity. And we have business models that will reward flexible charging. And the objective is to learn about the charging behavior. We also have to learn about how flexible the EV users are willing to be. And we have to learn about the effects of the smart energy management and also the effect of economic incentives. And we have defined a set of indicators that will be used to measure and to evaluate what we want to look at, to learn. Yes, so I will talk a bit about the data collection from these demonstrators because that is a prerequisite for the ability to evaluate it. We collect data in 3 different ways. We do surveys by means of questionnaires, interviews, and also document studies. This is very much qualitative data that we will collect in this way. In addition, we collect the quantitative data by means of automated data collection from software systems. So the data content is the same and has the same structure across all the demonstrators. And the data that we collect is designed to facilitate automated calculations of the indicators we are looking for. And we also have software that will visualize the indicators. And we also have data from simulations that is the same data content and structure as for the automated data collection. It's very slow, yes. So I'll focus on this because it's perhaps the most special type of data collection. We can look at one demonstrator and the measures realized in the demonstrator as a neighborhood, an energy smart neighborhood. And with here it is a big neighborhood. In reality, the demonstrators are smaller, as I showed you for Oslo, like the garage and the building blocks. But we can look at it this way, and we have to define the devices in the neighborhood that produce energy and use energy. For example, heating and cooling devices, the electric vehicles, stationary batteries, solar plants, and so on. In addition, we also have to define devices that deliver data, energy meters, charge points, software systems, and different sensors. And we have also data about the price lists and the tariffs used. In addition to the static data, we also collect dynamic data while the demonstrators are running. And here is an example of all the software components that might be involved in one demonstrator. And we collect data on charge point bookings. Let me. Oh, no, it went back. On charge point bookings and reservation, charging and discharging activities, energy production and energy use, also import and export of energy. It's not. It's not working. It's very export and import of energy, grid mix, energy cost, and also the weather conditions are important. And this will be logs with time series of data. So in total, all the data that is collected is a quite comprehensive information model with many relations between them that facilitates quite advanced calculations and evaluations. Yes, so I'll talk about how we do the evaluation and the learning. We use the Civitas evaluation framework as the method, as the main method. And as I have talked about, we have different measures that are implemented, and we have different indicators. And an indicator is a characteristics of a situation. So we have baseline indicators that describe the situation before we implement the measure. So here is no measure. In addition, we have indicators that are after values, after the implementation of the measure. And then the effect is the difference between the before and after, but we have to take away effects that are due to other reasons than the measure. So this is in theory how we will facilitate the learning about the effect of a measure. Oh, let me see. So this is our indicator framework. We have borrowed quite many indicators. The white indicators are borrowed from the Civitas framework. The yellow ones are indicators that we have defined ourselves. So we have, for example, indicators for the energy mix in the grid. We use the peak to average ratio. We have indicators about how flexible the users are, and so on. And to just summarize up how we facilitate the learning, we have measures in demonstrators, we have also simulated measures, and we have research data. We have an indicator framework. We have also defined methods for how the indicators are to be calculated by means of the huge amount of research data. And we have software doing the calculations and also the visualizations. By means of the collected data, we will do calculations, and then we will establish the indicators. And the indicators are input to the impact analysis. In addition, we will also do process evaluations. We will look at how we implemented the measures. We will look at to explain why we succeeded or not. For example, we can look at how much did we involve the user, might the involvement of the user or the lack of involvement of the user be the reason for the outcome of the impact analysis, for example. Did we provide them enough information and so on? And based on this, we will learn how to both affect and also about how to implement measures. At the moment, we are just about to start the research data collection, and we will do that from now in November and December. And we will go through and ensure that the data collection and also that the calculation of the indicators works as they should. And in January till September next year, we will collect the real research data that is input to the final evaluations. So we are really looking forward to be able to evaluate, and we see that the simulations becomes very important because, for example, in Barcelona and Bremen, we have demonstrators regarding charging at work, but those services will not be much used due to the COVID situation. So then it's very important to be able to simulate what will happen there. So it's more important that we thought it should be to be able to simulate the results. So that was it. Thank you very much.
Thank you, Mait. Nice presentation about our GreenCharge project, that is the sister project of MEISTER. Both were funded under the same call by the European Union. Let me ask Raquel if we have any question from the audience or any poll to launch now. Raquel?
Yes, yes, we have an answer question. Sorry, just it's addressed to Maria actually. So someone from the audience would like to know the spec data of delivery and will be the results shared through the website. Maria?
Sorry. You mean the results of the user research, right?
Yes.
We expect we are not submitted the deliverable, which is going to be submitted in January. So yeah, after the submission, we will publish the data on our website.
Okay, so the audience have to be stay tuned in order to get this information. Yes, we have another question, but it's a general one. So maybe after your presentation, we will address this question for all you the project. So just let me send you some other pools in order to let's break the ice again a little bit. Since we get a lot of information also from the GreenCharge project. So let me launch some questions here. So here's a question. So do you think that the strategic planning of EVs charging infrastructure in the cities could change the citizens' mobility patterns? Right. So yes, all of you think that it's possible. Another question here. So here another question for you. What is the main challenge regarding the charging infrastructures for you? So all of you think that the charging infrastructure costs, it's an issue, and also the poor capacity in local power grid cannot handle peaks. And the last question that I will ask here. So assume there are business models for compensating owners. Can private resources help solving charging? What do you think here? Well, I will close this question. So yes, most of you think that yes, privately owned charge points can be shared, and more than 30% think no. Thank you very much for your contribution. So after the presentation, we will launch other questions. Please try to any question that you have, you can share on the platform. So don't hesitate if you have any doubt, any question, or any thought that you want to share with the speakers, please write in the question side. Thank you very much.
Thank you, Raquel. I see that these polls are really interesting, so I encourage the audience to participate in it, and also, as you said, to post any question, any comment in the chat to any of the panelists or the speakers. Now, according to our agenda, let's move to the following presentation. Now it's time for checking the slides on the analysis of electric vehicle cost-based charging load profiles. Here the presenter will be Mr. Sotiris Deligiannis from the University of Peloponnese, and he received his bachelor's degree from the Department of Informatics and Telecommunications of the University of Peloponnese. His bachelor thesis was about analyzing the load profile using grid-to-vehicle and vehicle-to-grid technologies. And he's currently in a master course at the University of Peloponnese and a member of the Wireless and Mobile Communications Lab, where he continues his research in electric vehicles. So please, Sotiris, can you go straight with your presentation? I pass the role to you.
I think that I don't have the control, I think. I'm sorry.
Yes, you have it. Please try to pass to the next slide.
I'm trying, it doesn't change.
And maybe behind one of your windows or on a different monitor, you have a button that says to show your screen. You have to accept control in order to have it.
I can move the mouse, but I cannot share. I cannot continue to my presentation. I'm so sorry. Oh, okay. Oh, I'm sorry. So, hello everyone. My name is Sotiris Deligiannis, and I'm a master's student from the University of Peloponnese. This research is about the analysis of electric vehicles for cost-based charging load profiles. It's a little bit slow. So, nowadays, the transport using fossil fuels causes the major problem of carbon dioxide, so electric vehicles are a promising alternative in order to analyze the impact of power demand and reshape the load profile using different charging scenarios. Electric vehicles are characterized from their battery capabilities and from their consumption. They can charge whenever a charging station is provided according to different charging strategies. Also, we try to control the electricity price in order to postpone some of the charging sessions. There are two key operations. There is the G2V, grid-to-vehicle, and vehicle-to-grid V2G operation. G2V refers to charging using a specific charging power, like uncontrolled and controlled charging strategies based on the electricity price using slow, fast, and ultra-fast charging. On the other hand, V2G refers to discharging using a specific discharging power, so electricity returns back to the grid during a discharging session. This amount of electricity is stored and used at peak times in order to minimize the power demand. Also, V2G operation requires longer plug-in session than G2V. The main charging strategies are the basic charging strategies, like the uncontrolled charging strategy, that electric vehicles charge whenever they are parked. And there are the cost-based charging strategies, like the external charging strategies and the individual charging strategies. At the external charging strategies, the charging is controlled by the electricity price. And at individual charging strategies, individual price incentives sent to the user in order to postpone a charging session. Now for the interaction with the grid, electric vehicles connect to the grid for a specific duration for charging and discharging session. The electricity price varies through the day in order to calculate the load profiles and extract useful information about the power demand. Now, there are also three different charging scenarios. At the first scenario, the electric vehicles charge according to G2V operation based on uncontrolled charging. So electric vehicles charge whenever they are parked. For the duration equal to the whole connection time. This refers to the base scenario due to the high power demand. At the second scenario, electric vehicles charge according to G2V operations based on the external charging strategies. So variable electricity price appear in order to postpone some of the charging session. It's determined if the electricity price is high or not. So for example, if the electricity price is low, the electric vehicles charge. But if the electricity price is high, the electric vehicles charge only if there is an absolute need. At the third scenario, grid-to-vehicle and vehicle-to-grid operations coexist. Both price incentives and the electric vehicle battery state of charge determine if the vehicle is going to charge or to discharge. If the price is low, the electric vehicles charge, but if the price is high, the electric vehicles charge if their battery state of charge is lower than 60% of its maximum capacity, and the electric vehicles discharge if their battery state of charge is higher than 60% of its maximum capacity. There is also simulation for each scenario for day Monday. Results like cost for charging, fuel driving, the average state of charge, and load profiles appear as well. The Monte Carlo simulation of electric vehicles driving pattern through the day uses data from the National Household Travel Survey and the Nord Pool. Our input parameters are the number of vehicles, the time step, the charging power, the maximum battery capacity, the vehicle consumption due to electricity, the vehicle consumption due to fuel, the minimum level of the battery, the number of days, the fuel cost, the battery level for G2V flexibility, the battery level for V2G flexibility, and the Monte Carlo iterations. Now, these results refer to the average level of state of charge for scenario 1 and from the probability of switching to fuel consumption while electric vehicles drive. The duration of the simulation is 24 hours with the time step equal to 30 minutes. Also, we ran the simulation for 10 kilometers per hour to 50 kilometers per hour. At the first figure for scenario 1, the average level of shock, the peak time is at 8 o'clock in the afternoon with a value equal to 80%. And we can see that as the vehicle speed increases, the average level of shock decreases from 10 kilometers per hour to 50 kilometers per hour. Also, for low driving speeds like 10 kilometers per hour, the average level of shock is equal to 80%. And for higher driving speeds like 40 kilometers per hour and 50 kilometers per hour, the average level of shock is lower than 60%. Also, the probability of switching to fuel increases while the electric vehicle's velocity increases from 10 kilometers per hour to 50 kilometers per hour. We can also see that as the shock reaches the minimum values, the probability of switching to fuel reaches the maximum values. Okay. Okay. These results refer to the load profiles for scenario 1 and for scenario 2. At the first figure, the peak time is at 6 o'clock with a value equal to 4 megawatts. Also, the power demand fluctuates from 2.5 megawatts to 4 megawatts. At the second scenario, the peak time is at 10 o'clock at night with a value equal to 8 megawatts. The power demand fluctuates from 2 megawatts to 8 megawatts. Also, before the peak power demand, the minimum value drops below 1 megawatt just before 9 at night. Okay. Okay. There are also some aggregated results for the entire day for each velocity, like the average load profile and the cost for charging and the total cost for each scenario. We can see that for the first scenario is higher than the other scenarios in both figures, and the third scenario is lower than the other scenarios in both figures as well. So we can understand that by returning energy back to the grid, the lowest power demand appears and the lowest cost for the driver appears also. Now, in conclusion, charging policies based on price incentives and constraints can be used to reshape power load profiles, and electric vehicle owners may benefit from lower charging expenses. Also, by increasing the average driving speed from 10 kilometers per hour to 45 kilometers per hour, results at 20% reduction in the electric vehicle average shock level. This work is currently in progress, so we have to model the relations between some systemic parameters like the charging power, the average driving speed, and the duration of a full charge. That's all from me, and I'm really thankful for your attention.
Thank you very much, Sotiris. This shows real and impressive data of your research. So I have to ask now to Raquel, do we have any questions from the audience at this point? I guess not. Raquel, can you hear me?
No, we don't have, as I said before, we have a general question, so maybe it's better if we answer this question all together once it's already done. And okay. Yeah, we will end up after the last presentations, we will launch 3 other polls at the end of the session.
Okay, so now it's time for the last presentations. It's about electric vehicles charging infrastructure for improved user experience. These presentations is going to be made by Evangelos Karfopoulos, sorry for the pronunciation in Greek. And this project is a sister project of UserChi project that was presented before by Maria. So now I will pass the floor to Dr. Evangelos, but first of all, I will share with you some words about him. He received a diploma in electrical and computer engineering. He also have a PhD degree for his research on optimal management of electric vehicles for their efficient and effective integration into electricity networks. He has been working as a senior researcher in ICCS in the mobility area, and also distributed optimization and Java programming. Currently, he is the senior project manager at ISNIS research group, and in the ETRA. And he's been involved in several European projects as well, and with the role of technical coordinator. And furthermore, he served as a senior researcher in the ETRA telecom, focusing on distributed energy flexibility markets. He has published a number of scientific journals and articles in scientific journals and conferences. So please, Mr. Evangelos, can you proceed with your presentation? Now you have the role.
Thank you very much, Patricia. Today, my name is Evangelos Karfopoulos. I'm a senior researcher in the Institute of Communication and Computer System, who is coordinating the project ETRA for drivers. The aim of this presentation is mainly not to provide any tangible outcomes from this project, because we are running the 5th month of the project life, but rather to provide the vision and the objectives of the project, as well as to give you insights on the charging technologies and services that we are proposing, we're going to develop and demonstrate. Some introductions. When a user comes to the time to purchase a vehicle, in case the user wishes to purchase an electric vehicles, he or she came up with 3 main questions. Why should I pay more for an electric vehicle since I can buy the same model with lower cost like the conventional model one? The second question is, why should I need to purchase an electric vehicle and save my habits? As we all know, sometimes it's difficult for a user to accept to change habits that many years before exist and he is used to live with them. And the last question is, if I have an electric vehicle, where I can find a place to charge my EV? These 3 questions are the main users' concern that prevent the boost of the e-mobility in many European countries. So if we wish to see some generic concepts how these 3 major concerns can be overcome, starting from the high cost of the vehicle. It's true that even though the battery cost has significantly reduced within the last few years, within the last 10 or 20 years, still the vehicle cost, the capital cost of purchasing an electric vehicle is rather high. In this respect, at national level, many financial and non-incentives have been decided in order to promote the purchase of an electric vehicle. But this is not enough. There are also other concepts that we can skip the concern of the capital cost from an electric vehicle. And this is why we can find new concepts. The idea is that the main additional cost of purchasing an electric vehicle is the battery cost, and not the technology itself. So there are some concepts that can allow a user not to invest on the capital, but to invest on the technology without investing on battery or electric vehicle. The first one is the car sharing concept. Electric vehicles can be used, light or passenger electric vehicles can be perfectly fit under the car sharing concept, where the users can share a vehicle without investing on the capital cost, but rather affect the operational cost. Another concept is the battery leasing or the battery swapping. There are some automotive industries that they're providing technologies, vehicle technologies, with or without the battery. So if you can purchase the electric vehicle without the battery and have a leasing plan with the same company in order to lease a battery and pay a monthly cost. So you're transferring the capital initial cost of the battery into operational cost, which is distributed among the life cycle of the vehicle. And then we have the concept of a battery swapping charging technologies where you can change, you can drop your empty battery and pick up a fully charged one. The last concept is the more advanced one, is the services that can be provided from the vehicle. The vehicle can be utilized not only for the mobility purposes, but it can be used as a storage in order to provide services to different e-mobility and energy stakeholders. Either it is through the e-mobility service provider. Either we are talking about market-oriented services or grid-oriented services or prosumer and energy communities-oriented services. The second concern, the user acceptance. In order to persuade people, users, to purchase an electric vehicle, we have first of all to provide them user-friendly and interoperable charging solution. And this charging solution should be really user-friendly and should reflect the needs for using such charging, the user needs and prospects for using such charging stations. Users should be able not only to use charging station, but we should complement these charging technologies with advanced e-mobility services that will facilitate the access as well as the usage of the charging station and maximize the charging experience of the end users. The reluctance of users to purchase an electric vehicles due to the fact that they have to proceed with the charging process, that it is completely different with the refueling of conventional car in terms of time that needs to charge the car, as well as the places where they can charge the car. In that sense, we have to explain what are the real benefits of purchasing an electric vehicle. I will give you an example with the mobile phones. During the late 90s, beginning of 2020 decade, most of us, we have a mobile phone that needs, that we were charging it once per week. Then we had the smartphones and the need for charging once per day or once per 2 days was something that provided discomfort to the user, but no one complained that I don't want this new technology. And I can bet that 99%, if not 100% of the entities, all of us have a smartphone and we charge probably once per day. So we have why we select to use smartphone, because the added value that it is provided by and the services that are provided by smartphones are real much better than the service provided through an old technology mobile phone. So concerning the mobility, we have to clearly and transparently explain to the users what are the benefits at individual level as well as society and environment level. The last one is the lack of charging network. It's especially in cases in countries where the e-mobility is in a premature phase. And this is because charging point investors are not willing to invest in charging point networks if there is not a critical mass of electric vehicles on the road, because in that sense, their investment is not sustainable. How this can be overcome? First of all, we need to incentivize and support the development of charging infrastructure, especially public ones. And we should also incentivize different and diverse charging technologies for passenger, for light electric vehicles, private, public, AC, DC. Users should have all the options on the table in order to be able to follow different preferences and fulfill all the needs of the users. The development of a charging network, especially public one, should be done in a coherent way and it should be planned based on locational planning tools that provide the best solution and the optimal placement of the charging network within roads, within a city or at national level. And finally, we should maximize the reusability of the charging points provided by the charging point operators by facilitating roaming services which enable the connectivity of the users with the same RFID card or with the same way in different charging point operators' charging facilities, as well as facilitate roaming in terms of payment. What are the vision and the objectives of the Charge for Driver project towards this concern? The Charge for Driver project, as I mentioned before, started June. It is running now the 5th month of the work. We don't have tangible outcomes right now. We are in the position of creating a survey in order to capture user perspectives, users' concern, not only EV users, but also non-EV users, in order to be able to track what are their concerns or what they think are the obstacles for not purchasing an electric vehicle until now. We have 10 demonstration areas to cover urban and longer trips, and the consortium comprises of 32 partners, including charging point operators, e-mobility service providers, research institutes, academic partners, municipalities, etc., and European associations. The strategic objective of the project is to develop and demonstrate a user-friendly charging station and smart charging solution, not only for passenger vehicles, but also for light ones, electric bikes and motorbikes. The second objective is to enable interoperability in order to enhance not only the information exchange to the user, but also to facilitate the development of advanced e-mobility services for the user, to maximize the user experience. In order to maximize user benefits, either this is translated in charging cost or the utilization of renewable energy resources for charging and electric vehicles, smart charging concepts will be developed with different business objectives and strategies. The fourth objective is to deploy and demonstrate innovative charging solutions for light electric vehicles, comprising the mobile charging services, charging the electric vehicle on the road, as well as battery swapping stations for light electric vehicles. The fifth objective is to understand the user needs and preferences by conducting online surveys before the implementation of the eCharge for Driver solution, charging solution and services, as well as after the implementation and demonstration of the project solutions. And finally, the sixth objective is to accelerate the deployment of the charging infrastructure by providing tools that will facilitate sustainable and user-friendly charging network developments. This is the concept. We can split in three parts. On the left part, you can see technologies that will be enhanced or proposed. For example, we will enhance the already existing DC charging stations with enhanced larger user screen, providing the users with more information concerning the charging process and the charging billing. We will develop also combined and modular charging station that a central charging station can serve simultaneously charging stations for passenger electric vehicles as well as for light electric vehicles. And all these charging technologies will be combined with the respective backend system for monitoring and management purposes for a charging point operator. In the middle, we have the services that will be built on the top of the CPO monitoring and management capabilities. Services could be indicative services are the enhanced planner and booking, payment with one contract, predictive battery diagnostics services, as well as smart charging control. And then on the right hand, you will, as you can see, some new charging concept, which is the mobile charging service for charging the electric vehicles at places where there is no charging point nearby, or the battery swapping station for the light electric vehicles. And for the cities where there's no enough space for developing charging infrastructure, we will demonstrate and analyze the solution of the lampposting charging stations. How the project, the Charge for Driver solution, will respond to the challenges that were mentioned before. How we can increase and improve the comfortability of the charging session. First of all, we will make a wide online survey in order to analyze the user needs as well as the user patterns, traffic and parking mobility and parking patterns, as well as charging patterns, in order to combine what are the users' preferences and what are the users' real profiling, charging and mobility profiling, in order to provide more user-oriented services and technologies. Interoperability is the main focus of the project. All the services and charging technologies will follow open standards that are existing in the mobility era. And then in order to improve the searchability and the accessibility of EV users to the charging stations, enhanced book services as well as route planner will be developed. All these services and charging infrastructures will be equipped with enhanced charging information, where the user can have information not only before accessing the charging station, but information during and after the charging process. Interoperability will be ensured by implementing specific protocols related to the communication of electric vehicle with a charging station, the ISO 15118, in order to be able to track information, to gather information from the vehicle. Otherwise, if we don't implement such protocols, we need to capture this information from the user. And since we need to maximize users' experience, we need to reduce as much as possible and make simpler the use of services and minimize the interaction of the user. The OCPP will be used for the communication of the charging point operator with the charging infrastructure, and for the e-roaming services for billing purposes, as well as for information concerning the operational and statical, the technical specification of the charging station. We will use OCPI as well as roaming platforms such as Hubjet or GA. The smart charging suite will be developed, enabling users to shift their demand based on different objectives, either it is price-based or power-based or consuming renewable energy resources, etc. Then, apart from the passenger solutions, we are providing charging solution and services for light electric vehicles. Battery swapping and mobile charging are the main technologies provided for them. And in order to support the wide deployment of charging infrastructure in a coherent and the most appropriate way, we are focusing on developing a charging location planner tool. Incentives and tariff schemes will be discussed and designed and will be demonstrated. And then recommendation and guidelines will be provided for the technologies and also to authorities and regulatory bodies. A quick overview of the structure of the workflow of the project. It can be divided in three, let's say, phases. In the preparation phase, we will try to analyze the user requirements for the charging infrastructure and the charging services on two ways, based on online surveys and questionnaires that will be distributed in its demonstration area, as well as based on data that will be provided by CPOs and EMSPs in order to have a better and more customized profiling of the users in that specific areas. Based on these requirements, the charging infrastructures as well as the services will be developed, and then in the second phase, these new technologies and services will be demonstrated in 10 pilot sites. After the demonstration, we will have again the analysis phase where the solutions, the charging technologies, as well as the services will be evaluated, and the user experience will be captured again through online surveys and questionnaires. The technologies that will be demonstrated on the left top, you can see the advanced DC chargers that will be developed by ABB and will be enhanced using the ISO 15118 protocol in order to maximize the information flow from the electric vehicle and minimize the need for user interaction, for example, providing the battery state of charge of the vehicle. This interaction will enable to provide more customized information to the users during and after the charging sessions. On the bottom left, we have the low-cost DC charging station for passenger and light electric vehicles. Here we are going to develop low DC charging station supporting unidirectional as well as bidirectional energy flow. For this reason, in order to be able to demonstrate the vehicle to grid flow, energy flow, we have the Volvo as an automotive industry which will provide an electric vehicle capable of supporting bidirectional power flow. On the right top of this slide, you can see the mobile charging station where we have a truck, a battery truck, which is driven by a bicycle, and then the user, wherever it's parked and there is no charging station nearby, he can make a call and book this battery truck in order to charge the electric vehicle at that specific parking point slot. On the bottom, we have the battery swapping stations where light electric vehicles, a user can drop the empty battery and change it with a fully one. You can see in the picture the different racks where the different battery technologies can be placed in order to ensure that different scooter vendors can utilize the same charging facility and support different battery technologies, which is really a not easy task. Concerning the services that will be developed in the ETRA for drivers, first of all, concerning the ISO 15118 specific tutorials will be developed for the training of charging point operators as well as EV manufacturer, and testing processes will be developed in order to allow conformance tests either for the vehicles that will be developed, constructed for supporting ISO 15118, or for the development of new charging technologies that will be compatible with ISO 15118. An enhanced route planner will be developed for enabling users to find the most suitable charging station according to their mobility restrictions, their preferences for quick charging, for slow charging, price profile they wish, as well as the real-time availability of the charging station. In the enhanced route planner, we also need to consider multi-user planner, which means the route planner service should consider concurrency when multiple users wishes to drive towards the specific charging station or towards a specific area, which this will create a bottleneck to the specific charging station. So the route planner should somehow handle this concurrency from user requests and allocate users in different charging slots in order to avoid issues concerning the occupants of the charging station. We have enhanced booking services providing real-time monitoring of the status of the charging station, if they are available or if another vehicle is using the charging station. There are parking sensors to indicate if a non-EV user, a conventional car, is using the parking slot, even though this is not allowed by non-electric vehicles. Booking service concerning the estimated cost, as well as you can request the booking service and search for a charging station, providing information related to the environment where the charging station exists. For example, if there are nearby restaurants or shop, in order to have a more pleasant time during the charging process. Smart charging services will be developed considering prices in order to minimize the charging cost, considering power constraints, for example, as it mentioned before in other projects, in case of parking, of parking places where the maximum power allowable for the grid connection is specific. Smart charging that enables the consumption of renewable energy resources at local level and creating such synergies between electric vehicles and renewable energy resources. Integrating electric vehicles into micro concept where different renewable energy sources lies, different flexible loads as well as storages. So we would like to see how all these distributed energy sources can be combined, including also electric vehicles. And then a battery aging prevention, where this service monitors and tracks the operation of the battery and makes an aging analysis. And based on these results, the service proposes what is the best, the optimal charging profile for the specific vehicle in order to minimize the aging and prevent damaging the health of the battery. And this is the predictive diagnostic services, which aims to provide this optimal charging in order to reduce the aging of the battery to the CPOs or to the MSP, or maybe directly to the electric vehicle, to the battery management system. The location planning tool, which mainly focuses on the public administration and private players in order to optimally develop in the most efficient way, develop and plan a charging network considering user needs, network capacity, as well as the different charging technologies, AC, DC for passenger and light electric vehicles under the same planning tool. The output of this tool is the optimum mix of the charging options as well as the respective location to be installed, the charging stations to be installed. A web interface, a user-friendly web interface with interactive map in order to provide and visualize the output of this tool will be provided. And through this user-friendly web interface, the administrations and the private players can simulate different scenarios representing different penetration level, considering EVs and light electric vehicles, in order to make a scalable planning. Concerning the data collection, the aim is to capture user perspective and user concern and preferences, not only before the demonstration, but also after the demonstration of the ETRA driver solution. Now we are developing the online survey for capturing user perception and preferences, charging preferences. The survey will be launched probably mid of November. The target is to have averagely 800 questionnaires per each demonstration area. So we are expecting to reach 8,000 responses in order to track users' perspective and perceptions right now in 10 different demonstration areas. And then for the development of services and charging infrastructure, We need some more details concerning the user requirements, and for this purpose, we will have private peer-to-peer interviews with investors and authorities in order to define their needs, their concerns, especially what are the incentives that should be provided, what are the tariffs, the price tariffs, or what are the penalties when inappropriate behavior from EV users or non-EV users occur. Concerning the analysis phase, we will study the impact of the project development on the user charging behavior and experience. We will formulate guidelines concerning the fast charging infrastructure and what is their grid impact and how we can minimize this grid impact considering local renewable energy resources as well as battery storages. The conformance guidelines and testing of ISO 15118 and e-roaming. We will analyze market models in each demonstration area and which of them best fits to each demonstration area. We will prepare a recommendation to harmonize regulation and legislation among regions, and also guidelines for investors and authorities, mainly focused on the tariff schemes and alternative revenues. Finally, what are the expected impacts? We aim to maximize the user acceptance, not only on the early adopters, but examining different categories of EV users, as well as to promote e-mobility on non-EV users. To foster the investors to invest in charging infrastructure by providing them the appropriate tools for facilitating the proper planning of the charging station in order to make their investment sustainable. Determine legal gaps that are mainly causes it's the obstacle for the expansion of the e-mobility, especially in cities. Improve the interoperability concerning the interface between the vehicle and the charging technologies, as well as the interfacing between the different e-mobility actors. Better integration of high-powered charging stations, and finally, a standardized charging solution and payment system for light electric vehicles. The demonstration areas are the Barcelona, Grenoble, Berlin, Luxembourg, Zelig, Bari, Austria, Northern Italy, Greece, and Turkey. These are the 10 demonstration areas. 10 demonstration areas with different level of e-mobility penetration, charging station development, different regulatory frameworks. So for each demonstration area, we wish to demonstrate and implement and analyze what is the best solution considering the current situation of each demonstration area. If you are interested in a specific technology, charging technology or charging service, feel free to contact us, and we will bring you in contact with a specific pilot leader to have a better and more detailed discussion on that. Thank you very much for your attention.
Thank you very much, Vangelos. Thank you for your presentation as well. Really amazing what we are going to achieve for the impacts you pursue in your project. And now I think it's time for launching some polls and also to check if we have any question or any comment from the audience. Please, Raquel.
Hello, everyone. Thank you very much for your presentation. Well, we will end with another poll. So please try to answer the 3 last questions that we are going to ask you. So assume you have an electric car. Would you allow flexible charging? Well, I think here most of you have already voted, so I will close this question. I will share the results. So here, half of you think that yes, charging can be done at any time before a deadline, and 50% of you consider that it's not possible. So here, a second question we would like to answer. So what charging option would you like to use in the future? Okay. So yeah, well here, 33% thinks that fast charging options. Another 33% use user-friendly charging stations, and the rest of you think that smart charging it's needed. So I would like to just ask you the last question from our side. So for which type of service would you like to use an e-mobility application? Booking services, route planning, to search for a charging stations or others? Okay, most of you have already voted here. So here is the result. So most of you think that would you like to have a application for searching for a charging stations, and some of you prefer booking services. So thank you very much for participating in our polls. And now I would like to ask you some questions from the audience to the speakers. We have a question regarding how COVID is affecting the development and the demonstration progress of your projects. You can maybe put your camera on again.
Yeah, it's Patricia. Maybe I can answer to this. From the perspective of MEISTER, and I guess that it would happen the same in the rest of the projects. But from our perspective, the COVID lockdown affected directly in the project activities, especially because when the pandemic rise, our project was facing the previous or the preliminary activities to the demo phase of the project. So most of these activities were stopped, were delayed. But now new deadlines have been set for these activities. We are again on track, and we are trying to recap things, and we think that the project is progressing now as forecasted. But of course, we have asked for the European Commission for some months extension of the project. On the other hand, if you ask me about how COVID is affecting the mobility in general in our cities, in our countries, I would say that from the MEISTER perspective, we are promoting those sustainable modes, such as the e-car sharing schemas, of course, using electric vehicles that can palliate or can alleviate these COVID restrictions, for example, for social distance that is really difficult to achieve in for example, in mass public transport. Also, the software development of MEISTER can contribute to digitalize the transport processes, also by means of intelligent transport systems. Within that, we contribute actively to palliate the COVID effects on mobility. And now I encourage the rest of the speakers to answer as well to this question.
Okay, yeah, in the UserChi case, we have dealing with this situation from the very beginning of the project. We started in February and we start with the travel restriction and lockdown in March. So we have adapted our work to the full online activity. Especially we have impacted in the user research when we planned to do many user research surveys, focus group with the users, and we have transferred all of this activity to online platforms like SurveyMonkey or Delphi questionnaires online. Yeah, it's have been an extra work, but I think we have been adapting well to the situation.
Concerning the ETRA for Driver project, since it started on June, I would say that we don't have any issues concerning demonstration and development because we are at a very elementary phase now. So what we are trying to do concerning the COVID effect is we are gathering real CPO and EMSP charging point operators data, as well as data from e-mobility service providers in the demonstration areas. And we are trying to have data 1 year before in order to capture what was the charging and mobility profile last year and what was the mobility and charging profile during the COVID period. It's not an easy task. We don't have all this data, but our aim is to, based on this field data analysis, to provide quantitative results concerning the COVID effect on e-mobility era. Concerning the workflow of the project, I think that more or less is the same in all projects. No physical meetings, only virtual participation in virtual conferences. I mean, all the administrative issues that all projects are facing due to the COVID effect. But for the development and the demonstration, we are far away from that, so we don't have major issues on that.
Yes, I can report from the GreenCharge project. We have extended the project by 6 months, and we hope that the situation would improve during the autumn, but now we see that it's even worse than before. And we are concerned about some of the demonstrators, because we have 2 demonstrators that address charging at work, and we have one that is about using e-bikes for the last mile towards work. And now with the home offices, people are not traveling to work and they are not allowed to be there. So we are concerned about getting enough data about the use of the chargers and e-mobility services. So as I mentioned, we will try to use simulations more than we originally planned. We also will make surveys to get data about how people traveled before the COVID and during the COVID, and how they think they will travel after the COVID, and use that input to make simulation scenarios. But we don't think that the situation after the COVID will be like it was before the COVID. Then it will be a new normality. People will perhaps continue to work more from home, and they may also travel in a different way. So it's very difficult to make realistic scenarios about what the situation will be after the COVID. But of course, we have to do the best we can. And of course, we also use online meetings and such things instead of meeting physically. Yes.
I would like to say that we need to run more simulations, and we need more data because of the mobility. Due to lockdowns, we are having a very low mobility at the lockdowns. So we need more simulations about that. And yes, that.
Okay, I have another question for you. Which are the challenges concerning interoperability on charging technologies and services? Anyone can answer the question?
In my opinion, I think that interoperability is necessary to ensure the easy and seamless connectivity of electric vehicles to the charging station. But when we are talking about interoperability, the majority of the people may think about roaming service and payment service. And the next statement after this thought is that we can ensure, let's say, somehow interoperability and on payment system by using ad hoc payment through a POS system. But interoperability and roaming should be something more than the payment process. Interoperability and roaming should be also considered on the service layer and the business services that can be provided from the mobility service provider to the users. And these services are the ones that will facilitate the accessibility of the user to the charging infrastructure, as well as they will increase the comfortness and information to the user during and after the charging. So interoperability should be seen not only on the technologies, which is more or less in a rather mature phase. For example, all the plugs more or less are standardized for both passengers and light electric vehicles. Some protocols concerning the communication of the charging infrastructure with the backend system of the CPOs using OCPP. The protocol is already there, but there are some standards that should also be implemented from the industries. For example, the ISO 15118, which will enable the information flow from the vehicle to the charging infrastructure and in the end to the CPOs and the MSPs, which will enable more information to the user, more interaction, better interaction with the user, like real-time interaction during the charging process, and better controllability. For example, the majority of the services provided by the MSPs needs the information of the state of charge of the battery. Unless the vehicle can provide it through standard protocols, the user will be asked to provide it. This is not really convenient, and maybe user is not comfortable or reluctant always using an application and providing the same input all the time. So in that sense, we need to facilitate the implementation of advanced services, mobility service to the user by implementing all the up-to-date standards concerning the communication flow from the vehicle up to the MSP level. And concerning the roaming, this can be done for the information flow for payment as well as charging, the status of the charging station, either peer-to-peer communication protocol should be implemented and deployed, or the implementation of roaming platforms.
Yes, I completely agree with Evangelos. I think he explained very detailed and very well the situation and the problems that the user lives, and the interoperability should be happen from the reservation, authentication, charging, payment. Yeah, all of these steps should be considered, and yeah, we will have interoperability when people stop talking about it, because when we have the full interoperability, we don't know what is happening in the backend, and we only go and charge our vehicles without any barriers.
Okay. Anyone else have to add any thought it is regarding? Okay, so next question actually was directly for Evangelos actually also. So for eCharge for drivers, how the charging technologies and services being designed in your project ensures that user charging needs and expectation will be considered?
An interesting question, because there was a question before in the poll about the opinion of the attendees if the user perspective are considering the charging infrastructure, and
Yes.
the answer is no, 100%. So this is interesting, how you can persuade the users first of all to participate in surveys for providing their preferences, and this is what we are trying to do in the ETRA for drivers. We are trying to make wide surveys in all the pilot areas, and as you see, we have very ambitious target. We are targeting 8,000 responses, which means averagely 800 responses per demonstration area. And the idea is that we wish to cover different questions targeting different impact areas for concerning the usage of the charging technologies and services, concerning the quality of the experience that they have or they wish to have, concerning the user acceptance, concerning the technical performance of the charging solutions that exist. So the idea is to ask users their perspective, their concerns, targeting diverse user pool, from taxi drivers, delivery companies, EV users, passenger EV users, light EV users, as well as we are also considering non-EV users. We are willing to know, we are really interested to know for EV users, non-EV users, what are the obstacles, in their opinion, for purchasing an electric vehicle? What are their main concerns, in order to be able to reflect them in the charging technologies as well as in the charging services that will be developed in the ETRA for driver project. So I think that the wide survey that will be conducted at the beginning of the service, as well as the peer-to-peer interviews that we will have with experts, authorities, CPOs, etc., will ensure that all these outcomes of the survey will be reflected and translated into user requirements for the design and development of the project solutions.
Evangelos, and I would like to ask you, the speakers, another question. How important is the support from the municipalities, from the cities, and if you are getting this support actually from them?
Yeah, of course, it's critical when you are talking about charging infrastructure and electromobility strategies in order to foster this sustainable means of transport. So, of course, is key that the city, the region, or the government in general has this, let's say, this electromobility strategy in their agenda, and that they have the let's say the idea or the compromise to foster and to boost the not only the business models but also the measures that promote electromobility in the city, also integrating the measures and the design of these measures into the SUMs, the Sustainable Urban Mobility Plans, or within this process of city planning, because at the very beginning of this planning of the city, of the mobility, of the mobility planning or the transport planning of the city, is when you can allocate really strong measures in order to foster this means of transport, of course.
Yes, I agree. It's very important to involve the cities, and we have two cities in the project. We have the municipality of Oslo, and we also have the city of Bremen in the consortium, and they actively participate. We have also activities on sustainable urban mobility plans, and we have also a list of follower cities that contribute and participate in that work. So we try to give feedback about the lessons learned into this work on the SUMPs. And it's very important to have some to get e-mobility into the SUMPs, but because it's not there today. So that is important, I think. And to provide with some guidelines on how that should be done.
Also, from my side, I fully agree with that cities and especially municipalities should play a key role in the development of the mobility. And I would like to give a specific example from Greece, that even though we are in a really premature phase of the development of the e-mobility, the recently adopted regulatory framework for e-mobility predicts that within a specific time frame, all municipalities are obliged to provide an e-mobility and public charging point network development plan for their municipalities. So this is a practical and a proof that municipalities has to play and should play a key role in this in the mobility development promotion.
Thank you very much.
Okay.
I don't know, Raquel, if you have more questions.
Just a last questions. Since I'm dealing with the communication and dissemination part of European projects, I would like to know from your side, from your opinion, what do you think is the most effective way to engage final customers or users in the electromobility? What do you think through workshops, meetings with the municipalities and the cities, through the European Commission's initiative, the media? I don't know. For you, what is the most effective way to engage the final users, in your opinion?
Okay, I will break the ice. Yeah, I think all of the solution, all of the alternative in dissemination are valid, have their particular audience. So these are really good. But we have a problem or a particularity nowadays, because we have our experience in this pandemic, one extreme increase in the events, and we are maybe losing audience because people is registering to many events, and maybe we don't know if they really are being engaged in the same way as before in presential, in face-to-face event and so on. So yeah, we have, I think, to be very imaginative and to propose something new, doing online events, because we have to do that and share information in our social networks and try to engage in a new way to the users.
All right. Anyone else wants to add any thought?
I agree with Maria. Also, in the Chance for Driver project now, we are trying to develop our distribution strategy for the online surveys that we are going to conduct. And we have, let's say, put on the table some of the common practices and prioritizing them, putting high priority to the social media for promoting online surveys, LinkedIn, Twitter, Facebook, the project site, etc., or the company's site. But there are some also some mechanisms that are proposed by other partners, have some kind of competition that you may participate in this demonstration activity, and you will get an iPad or a prize for this participation. So this can also be a motivation for the user to participate. In any case, in concerning the user engagement, first of all, we need to provide clear and transparent message to the end users what we are going to provide to them, and not provide them a technological background that we are developing this and that technologies. They are more interested in what are the benefits, how they will be benefit from the solutions that will be provided, the solutions to be provided to them. So it is important to highlight how the mobility charging infrastructure or the services will affect their behavior, will enable better accessibility to the charging station. All this stuff, how they will make our life easier concerning the use of an electric vehicle. And for sure, local people, local partners always are the key partners for engaging users at local level, since they have more tight social bonding with the local people. They speak their language and they have a better understanding of the local needs. So I think that more or less these are the key strategies and the ways to promote and support user engagement.
Okay, thank you very much for your answers. Well, that's all from my side regarding the questions that we have and I had. So I don't know if you want to conclude.
Yes.
Some points.
Yeah. Thank you very much to all the attendees to this workshop. It has been a pleasure to share the floor with those high-level speakers in this relevant e-mobility or related to electric vehicles projects. Just to remind the attendees that a survey will be launched as soon as this workshop has been closed, so please fulfill it, because it will help us to arrange and elaborate more in the next workshop we prepare. And please stay healthy on those times. Thank you very much again.
Thank you very much.